So now we're going to go back to our orders API, and we are going to talk about a very important topic, the topic of authentication. So normally when you have an API out in the open, you do not want anybody to be able to access it. You want to make sure that only people that you know and that is authorized to use your API is allowed access. So the examples that we've seen so far are really unrealistic and are done that way only for simplicity when we were introducing the concepts. But in reality, when you do any real-world API project, you will have to have authentication implemented. So now we're going to look at adding authentication to our orders API that we've seen before. So let's change to version 0.5 in our example. So I'm going to go ahead and do git checkout v0.5. And this one adds user authentication to our orders API. I'm here in the camera directory. I'm going to switch back to orders, which is the example that we're going to look at now. Let's take a look at this. To implement authentication, I'm going to use an extension that's incidentally written by myself. It's called Flask HTTP Auth. This extension allows me to simplify my work with HTTP headers related to authorization and authentication. Since I'm trying to be as RESTful as I can here, I'm going to use all the headers and recommendations from the HTTP protocol in regards to how I send my authentication information and user credentials. So Flask HTTP Auth will simplify that work greatly. So you can see here that I create an object of class HTTP basic auth. This is going to be the handler that will work with HTTP basic authentication for me. So let's see what we need to do to add authentication here. The very first thing that we need is we need users. We need to have a list of users that are allowed to access the API. So for that, I'm going to create a new model in my database. I'm going to call it user, and it's going to be a table named users. It's going to have a username, and it's going to have a password hash. The username is going to be 64 characters long. The hash is going to be long, so I'm reserving 128 characters for it. I'm not storing the password in my database. This is not the password. This is the password hash. So when I register a user and I set a password for it, I'm going to process that password, convert it into a hash, and this is going to be through a secure cryptographic function that is hard to reverse. So I will never know the original passwords for my users. This is very important because if one day your database gets attacked, the attacker will not be able to make much use of the hashes. But if you have the passwords there out in the open, then that could be devastating for your users. So I'm going to have two auxiliary functions here, methods in my user model that set and verify my password. And this is to abstract the managing of the hashes. So to set the password, I'm going to send the password as an argument, and then I'm going to use a function that comes with Werkzeug. This is the web server utility that is a dependency of Flask. Flask uses it for all the things related to web servers. And it comes with authentication and password hashing functions. So I'm going to use that to generate a password hash from my password. I'm going to store the result in my password hash, and that will go in the database. As you see, I'm discarding the original password. I will never be able to recover the password. So if a user forgets the password, the only way will be to give it a permission to change it and make a new one. You will not be able to recover the old password. The second method will do the verification, and here again I send the password and I use the second auxiliary function from Werkzeug, check password hash, and this will compare the hash that I have in my database against a new hashed version of the password that I have right now for verification. And if they are the same, then this is going to say true. If not, it's going to say false. So my user is now enabled to handle passwords securely. So then I have my remaining models, which did not change. I have customer, product order, item, And here comes another interesting part. When I'm going to work with the Flask HTTP auth extension, I need to tell it how to tell if a password is correct or incorrect. The way that works, as it works with many Flask extensions, is through the use of a decorator. So if you remember at the top when I created a HTTP basic auth object, that's here, auth. So auth provides me with a decorator that I can use to provide a password verification function. So I decorate my function with this, and now this function will receive a username and a password. And here my task is to return true or false, depending on the username and password pair being correct or incorrect. So I'm going to load my user, and I go back to this in a minute. Let's ignore that for a moment. So I store my user that I get from my database. If my user is none, then I'm going to return false. This is an invalid authentication request. If I get a valid user, I'm going to call user verify password, and this will return true or false, and I return that as the result of the function. Let's talk about G now. Many times when you handle a request, you need to know who was the user that requested it. So here we are going to be talking to the database, getting the user object. It will be a pity if we have to discard it only for the route then having to go at the database and retrieve it again. So what I'm going to do here is I'm going to use the G object. This is a context object from Flask that is enabled when a request starts and Flask pushes an application context. That enables G to live through that request cycle. So anything I set in G in a function is accessible in any other function that runs during the same request cycle. So what I'm going to do is I'm going to save my user in G instead of putting it in a local variable. And then that will enable any routes that run after this, after authentication was verified, to access the user just by saying g.user. And that saves the route from having to grab the user from the database again. So next we have a before request handler. So we are going to protect all the API endpoints that we have with the same method. So now all the routes will be password protected. We will need the user or the client to provide a username and a password every time a request is sent. The way you protect a route is by adding another decorator from Flask HTTP auth. Any routes that get the login required decorator will run authentication before the route is allowed to run. But in this case, I need to put this in all my routes, and I have a few of them. Since I want the same type of authentication in all my routes, instead of copy-pasting auth login required in every route, I'm going to set up the before request event, and then in the handler, I'm going to have the password checked. So now this is going to run before any of the routes, and the password verification will be done as part of the before request handler. Now, that's the only thing I need to do here, so there's really nothing to do inside the body of the before request handler. So all I do is just let the decorator do its job and verify the password. If the verification of the password turns out to be incorrect, then Flask HTTP auth on its own will raise an exception, and that will cause a 401 code to be returned to the client. And 401 is the HTTP code for unauthorized access. Here you can see that in the same way I redefined the default error handlers for Flask so that they are friendly JSON objects, I'm going to do the same for my 401 error. I'm using yet another decorator from the HTTP auth extension. Here, this is an error handler decorator, and it works exactly the same as Flask's own error handler decorator. Here, I provide my own response for the unauthorized access error. And I use the same style as before with a JSONified friendly dictionary with status, error, and message. And my response status code is going to be 401. And that is pretty much it. We have the routes, and the routes don't need to be modified because the before request takes care of the authentication. So what I'm going to do now is show you how this can be used. So the very first thing we need to do is to create a user. We have a new users table in our database, but we haven't created any new users yet. So we have to create one that we can then use in our authentication. So I'm going to do that manually. I'm going to start Python console. I'm going to import my database and my user model. Since I created a new table, just to make sure, I'm going to call create all. This is the Flask SQL Alchemy function that creates any tables that are missing in the database, comparing it to my models, so that if there was not a table for my users, that will create it. So now I have a users table. Now I'm going to make a new user, and I'm going to call him John. Oh. So there's John. I'm going to use my set password method, and I'm going to set password to cat. Now let me show you the password hash that was generated from this. And you can see here that there's absolutely no resemblance between the original password and the hash that we are going to store in the database. So now what I'm going to do is add this user to my SQL Alchemy session, and I'm going to commit the session. So now I have a user in the database. So we can exit our console, and now I'm going to start my application. So okay, now we have the application running. I'm going to create a second console here. We're going to leave that running, and we are going to try to get our customers like we did before, and see what happens now. Now we are not authorized to get our customers. This is called HTTP. This is the HTTP command that I'm using to send my requests. It's a really nice HTTP client, and I can use it to provide authentication. So I'm going to give it John password cat. And now you can see that the information was returned. So this user is authorized to obtain information. Anytime I send a request now, so for example, if I wanted to talk to my first customer, then I will need to send authentication information. Let's see what happens if I send the wrong password. Just to verify, let's make sure that yes, we get a not authorized error. So this is how authentication works in the simplest way. In the next video, we're going to see an improvement over this.